Hello everyone, welcome to this online mathematics class. As you all can see on the screen today, what we are going to learn about the new concept called the congruence. Okay, before moving on to the definition of congruence, let us see what actually congruence is and who is the person who has contributed more in this field of congruence. So as you can see on the screen, a congruence is nothing more than a statement about divisibility, but it means it is more similar to the concept of divisibility, and this concept that congruence was introduced by the person called Carl Friedrich Gauss. So he is the person behind this concept, and he has given some basic ideas, and also he has put some more important theorems in this field. So this is the small introduction related to congruence. Let us move on to the definition of congruence now. Let m be a positive integer if a and b if a and b are two integers such that m divides a minus b m divides a minus b, then a is said to be congruent to b modulo m. Okay, this is the definition of congruence, as you can see on the screen. Yeah, I think now it is visible for you. So this is the definition of the congruence. Let m be a positive integer. Another way of saying m is a positive integer is let m be any natural number. If a and b are two integers, it can be positive or a negative, such that m divides a minus b. If m divides a minus b, then we can say that a is said to be congruent to b modulo m. In symbol, how we can write it down, I'll show. So these are the three ways where we can write down this a is congruent to b modulo m. So these are the three ways. As you can see, a is congruent to, this is not equal. If you are putting three a sleeping line over here, that is the symbol for the congruence. Okay, a is congruent to b mod m. Or another way of writing is this, or if we are sending this b to the left side, so it will be a minus b, and we can write down in this place as 0. I mean, in place of b we can write down this 0, as I have shifted b to the left side. So these are the three ways where you can write down this is congruent to b mod m. So I'll repeat the definition once again. Let m be a positive integer. M be or in other way we can say let m be a natural number, and a and b should be integers. Integers means positive numbers, negative numbers along with 0, right? So it can be integers, then such that if m divides a minus b, then we can say that a is said to be congruent to b mod n. In symbols we can write this as like this. Okay, for a is congruent to b mod m. Thus symbolically I can write down this definition here. If small m belongs to natural number, this is n in the sense natural number, that is a symbol for natural number, and a comma b belongs to integer, if these two conditions, if these numbers we have picked, m from natural number and a and b from the integers, then then m divides a minus b, m divides a minus b, m divides a minus b, such that m divides a minus b is possible. If it is true, then I can say that a is congruent to b mod m. That I have written here in the symbol, that is if and only, that is if and only if a is congruent to b mod m. Okay, so this thing I can write down in this form also and this form also, that you have understood, right? So in symbolically, the same definition I have written here symbolically. You pick m as in any natural number and other two numbers from the integers, then this condition if satisfies, then this is true. Okay, if and only if condition means if this is true, this is true. If this is true, this is true. If suppose this is false, then I can write down it is a is not congruent to b mod m. I'll just put a slant line over here. So I'll write down in the next. If m does not divide, suppose we have picked some natural number and also I have picked a and b as integers. Suppose this condition is not true. If m does not divides a minus b, then we can say a is not congruent, or another way of not congruent in the sense incongruent to b mod m. In symbolically I can write down, we can write as a is not congruent to b mod m. Okay, that is a simple thing you should understand over here. If suppose m is not divisible, okay, this condition is not true, means I can say that a is not congruent or a is incongruent to b mod n, and I can write on just a slant line over this congruence symbol. Okay, that's it. That is the definition of congruence, and how we can write down in the three different forms. I can write down this a is congruent to b mod m, and if suppose m does not divide say a minus b, then I can say that a is not congruent to b mod m, and in symbolic I can write down in this form. Okay, that is the idea behind the congruence. Now let us see some examples. Okay, we'll say some. Okay, I have taken example 1 here. Well, I'll check whether a is the given example is congruent or not. 19 is congruent to 7 mod 12 or not. So if you are going to check this one, you just write it down what is there in place of 19, that is a is congruent to b mod m. So if this condition is true, in the sense mod means m divides a minus b should be true. We have seen in the previous definition where I have explained all those things. So I have written here m divides a minus b. So whatever the values are there, that is m, a and b, all those values I'll substitute over here. So I have substituted. So 19 minus 7 is nothing but 12. So 12 minus 12, yeah, it is possible, that is 12 ones are 12. So it is true. If suppose this condition is true, if this thing is true, then I can write down 19 congruent to 7 mod 12 is true, means that is possible. So this idea I have written here. So just to recall that m divides a minus b, what is the meaning of this? We have learned in the divisibility definition itself, it is nothing but a minus b whole divided by m. So this thing I can write down in this form. Okay, don't get confused what is the meaning of this, but I have written here slant line, that is that thing is different. M divides a minus b is totally different as compared to a minus b whole divided by m. So that is the meaning of here. Don't just write it down m is whole divided by a minus b, that is totally wrong. Okay, I'll be explaining over and over, so you just keep in mind all those things. So let me depict the example number 2 over here. So I have taken example 2 over here. So let me take a simple example, that is 17 is congruent to 3 mod 7. Okay, so I need to check whether this is true or not. Okay, so let me write down A is congruent to B mod M. So if this thing is true in the sense M divides A minus B is possible, right? So I'll just substitute the value here. What is M? That is 7. What is A? This is 17 minus, what is B? It is 3. So that implies 17 minus 3 is what? What is 17 minus 3? It is 14, right? So it is nothing but 7 divides 14. 17 minus 3 is 14. So this is true. If this is true, means that implies 17 congruent to 3 mod 7 is true. Okay, if this is true, this is also true. How it is true in the sense, how I can write down 7 divides 14. I can write down 14 is whole divided by 7. That is the thing I have explained here in the concept of so divisibility also. How I can write down. So this is like 7 ones are 7, 7 twos are 14. So it gives into, right? So it is possible that where I can divide that thing. So this is true. Similarly, I'll pick example 3 over here. Let me take 3 square is congruent to 1 minus 1 mod 5. So I'll just write down what is this 3 square is 9 is congruent to minus 1 mod 5, right? Minus 1 and mod 5 I have written here. So similarly I'll check here. So M divides A minus B, you can write down 5 divides, what is A here? I'll just write down, I have not written here. Okay, what is A here? A is 9, minus sign is there. What is B? That is also minus 1. So this I can write down, that implies 5 divides 9, minus into minus is plus 1. So that implies 5 divides 10. That is possible, right? That is nothing but 5 ones are 5 twos are. It is true. So if this is true, that implies 3 square is congruent to minus 1 mod 5, right? So I'll pick last example here where I'll show you where the congruence is false. Okay, the given congruent relation is false. So let me check. 17 congruent to 3 mod 15, that they are telling that this is not congruent or this is incongruent. So let me check. A is incongruent to B mod 5. So I need to check B divides A minus B. It is possible or false? I need to show it is false, right? So M is 5. What is A is 17 minus 3. So that implies 5. This is 14, right? So it is possible 14 whole divided by 5. No, it is not possible. So it is not possible. It is not possible. So I can say it's false. So that implies 17 is not congruent to 3 mod 5. So these are the some examples I have taken here. 4 examples where I have shown 3 as a congruence relation and 1 as incongruent and not congruent relation. So that is the idea behind that. And now let me write a simple note over here. Just copy that note. A is congruent to 0 mod M. Note number 1, M. This is possible if and only if M divides A. Okay. Second note is if A is congruent to B mod M, if and only if A minus B is congruent to 0 mod M. This is the possibility where I can write down. If I say M divides A in the sense A is B is 0 here. That is the thing I have written here. If and only if in relation in the sense, if this is true, this is also true. This is true, this is also true. If is different, if and only if different. If I write if, that is if. If I write iff, that is if and only if. If and only if in the sense, if this is true, this is also true. If this is true, this is also true. Okay, if I take this one, I'll get this. If I take this one, I'll get this. Okay, that is the meaning of that. So note 2 is I have written in the definition itself. Same idea I have written here. M does not divides. I'll write down again. Does not divide A minus B in the sense A minus B does not divides B mod M. Okay, that is a simple thing I have written here as a note. You just copy down all those things. Let us solve some simple problems over here. First problem, find the least positive integer mod 11 to which 82 is congruent. Okay, that is the idea over here. So I'll just write down what all the things they have given over here. Okay, so what they are asking, actually find the least positive integer. We need to find the least positive integer mod 11 to which 282 is congruent. The meaning is I'll write down here, 282 is congruent to which number of mod 11. In the sense A is congruent to B mod M, I'll write over here. So I need to find the what is the value of B here. That is the idea that behind this problem, what we need to find. So how I can find that? It's very simple, but remember that we need to find the least positive integer. Okay, the value should be least one. So by actual division we can have, so if you divide this one by actual division, in the sense if you divide all the 282 whole divided by 11, and you know how to represent these numbers, that is dividend is equal to divisor into quotient plus remainder. Okay, in this form I'll just arrange this one. You just check this answer. So 282 is equal to 11, that is your divisor, into what is quotient is 25 plus remainder you'll get as 7. You just check that one. So I have written directly over here. I don't want to drag the problem, so just write it down in this form. Okay, that implies that is your answer. Whatever the remainder you are getting, that is the least positive integer. That's it. That's simple as that. And 7 is the least positive integer such that I can write it down in this form. I'll write 282 is congruent to 7 is your B, right? We have found that is 7 mod 11. That's it. That's simple as that. So whenever in exam, if they are asking, maybe for 2 marks they may ask this problem, the least positive integer we need to find, that is the B value we need to find. So you just do the actual division how you are going to do, and whatever the remainder you are getting, that is your least positive integer. So that is your B value I have written here. Similarly, try to do the problem. I'll give as homework over here. Homework problem, try to do. Find the least positive integer mod 23 to which 290 is congruent. The same idea here, 290 is congruent to B of mod 23. So you need to find the B value. Only the thing is you have to take the actual division part and you will get the answer. So answer is I'll just give the answer. The B value should be the last answer is 14. Okay, you just check this answer if I'm correct. Okay, thank you, have a nice day.